Hi everyone, Lee here. I'm with Zinkers and the math content team. Today we're going to discuss a more challenging SAT question. And this is actually video 2 of 2, where we're going to look at this problem and solve it algebraically. But if you're curious to see how the problem is done graphically on Desmos, be sure to check out the video. So this problem says in a given equation, S and R are constants and S is greater than 0. If the equation has infinitely many solutions, what is the value of S? So something we discussed in the last video is to notice that X is on both sides of the equal sign. And if there's infinitely many solutions, what that actually needs to, what we need to start thinking about is that this is actually representing two different graphs. One is Y equals the left side of the equation, and the other is Y equals the right side of the equation. And if there are infinitely many solutions, that's when these two graphs coincide, where one lies on top of the other. So when we think about what these graphs, that there's two separate graphs here, and they're the same exact shape, we want to think about their shape. And this is where thinking about structure can help. I'm going to look at the right side of the equation because it's, simpler. But if you notice here, this is very similar to the structure of a line, y equals mx plus b. So we know m is the slope, b is the y-intercept. Actually, I'm going to use a different color. So if we use the structure of y equals mx plus b, we're going to be able to more easily figure out what r and s are in these equations. So I'm going to start by trying to convert these equations into this form. And I'm going to start here by distributing r, and we have y equals rx minus r times 8. And if we're using structure, that's going to allow us to identify that r is representing the slope of the line, and negative r times 8, that's representing the y-intercept of this line. If we can identify that on the other equation, then we're going to be able to use structure and match them up. What I mean by that, we're going to now simplify the left side of the equation and turn this here into this form. So let's simplify the 12x plus 28 over 4. 12 over 4, we've got 3x plus 28 over 4 is 7. Minus, this is an S over 13. So again, if we use structure here, we can notice that the number in front of X, that's our slope. Whoops, I want to use the highlighter. So 3 is our slope, and the 7 minus S over 13, that's our y-intercept. So what we can actually do here, we're going to use structure to match these up. Notice 3x is in the same location as r times x. So that means that 3x has to be equal to r times x. If it truly is, there's infinitely many solutions that make this statement true. So if that's the case, then r has to be equal to 3. Nice work. The question is asking us what is s. So we're going to have to take this value of r and use it to help us continue to solve. I'm going to focus over on the right side of the equation now. We have the value of r, so let's substitute it in. Y equals 3 times x minus 3 times 8. 3 times 8 is 24, so we've got 3x minus 24. And again, we're using structure to help us solve this, so that means that negative 24 has to be equal to this 7 minus s over 13. So let's write a new equation for that. 7 minus s over 13 is equal to negative 24. And this is just algebra now. So I'm going to add, subtract 7 from both sides. You can use a calculator if you need to. Negative 24 minus 7 is negative 31. So we have negative s over 13 equals negative 31. We're going to have to multiply both sides of the equation by 13. So negative 31 times 13 is negative 403. So we have negative s equals negative 403. We're trying to solve for s. One more step, divide both sides by negative 1. S equals positive 403. That is the solution that we were asked to find. What is the value of s? So algebraically, we found the answer. And in video 1, we solved this problem graphically. If you haven't checked it out, be sure to go check out video 1. Good work.